Hi, my name is Kaveeta. Thank you for having me. Pathogenic variants in Acta2, which encodes smooth muscle alpha-actin, predispose to heritable thoracic aortic aneurysms and dissections. Acta2R149C is the most common alteration. However, only 60% of carriers, denoted by an orange border on the pedigree, have a dissection or a repair of an aneurysm by 70 years of age, denoted with a black filler. We sought to determine how this mutation causes aortic disease. Using CRISPR-Cas, we generated an R149C mouse model. The mutant mice had significantly decreased aortic contraction compared to wild type, but did not form aortic aneurysms or dissections when followed to 24 months. Thus, our mouse model reflected the decreased penetrance of aortic disease observed in patients with this mutation, and our next step was to determine the mechanism. We questioned if decreased actin expression could lead to lack of thoracic aortic disease in the R149C mouse. Using an in vitro translation system with attention to the red font, we found that R149C actin has increased binding to the CCT complex, which folds all actins. We additionally found that a second site mutation N299T releases mutant smooth muscle actin from the CCT complex. We validated these findings in smooth muscle cells explanted from the mouse aortas using immunoprecipitation of the CCT complex, which demonstrated increased smooth muscle alpha-actin associated with the CCT complex in mutant smooth muscle cells. 2D gels also showed decreased cytoplasmic R149C actin levels in mutant smooth muscle cells compared to wild type, supporting that decreased levels of mutant actin were released from the CCT and available for cellular functions. In vitro studies demonstrated impaired assembly and interaction of mutant smooth muscle alpha-actin with formin, increasing actin nucleation and leading to less oriented actin filaments in the mutant cells compared to those in wild type. Additionally, myosin was shown to interact less favorably with mutant actin filaments. Together, these findings can explain the decreased ability to generate force in the R149C mouse aorta. In conclusion, our data indicate that despite the decreased contraction of aortic segments and disrupted mutant smooth muscle alpha-actin filaments, the R149C mice do not develop aortic disease. Enhanced binding of the mutant smooth muscle alpha-actin to the CCT complex may decrease the mutant actin monomer that's available for cellular functions and prevent aortic disease in these mice. Further studies to create the R149C and N299T mice are underway. Thank you again to my lab and our sources of funding.